Alright, we are recording, and what we have here is CIS-125, and we are on week 5. And here we did some review and a nested if example. First of all, review. We talked about some items here in terms of the boxes. A process box or calculation box, one arrow in, one arrow out. Input-output box, one arrow in, one arrow out. You never have more than that in those type of boxes. We talked about a connector. If you needed to jump from one place to another on a page or jump to another page, you can use a connector. Another one I didn't talk about, this one's often used as an off-page connector. You can use that one as an off-page connector. We can when we do a decision, when we use a decision, it always comes back to a connector. You can't come back to one of these type of boxes. You always come back to the connector and go from there. So a connector can have multiple in, one out. A decision will always have two out, one in. Start, one out, stop, one in. Then we talked about this area here. You can draw a line up and a line down and put some text here and make some comments in relationship to the box. If you can't get all the text, all the information you need in the box, or you want to comment to the box, you can draw that up, down, and put your information there. Alright, we talked a little bit about processing, and one of the students had mentioned in evaluation of a project, somebody had multiple lines in one box, or you create a formula and you put all kinds of things into the formula. When you look at it, for example here, we talked a little bit about, you bring the program up, put the program in memory, then the instructions have to come up and get processed. While the computer is working on, let's say an instruction has an input to it, as an input, and it has to wait for a response, it can go ahead and function other instructions while it's waiting. So there's some advantage to having this instructions not too big, actually an advantage of that. Alright, we'll go to the here we looked at an example. We said got the legend, and we said we're going to give test scores. So 90 and above gets an A, 80 and above a B, 70 and above, and then anything less than 70 we'll say it's not learned. Somebody, you don't fail, it just says you didn't learn it, and you got to go back and learn. So we talked about input, output, and process. You're going to put in their name and some score out of 50. The process will have to divide the score by 50 to get a percent, and then we'll compare this percent to our categories. We're going to print out the name, percent, and grade. We made a legend, and what we did, instead of putting 50 into the program, we said we're going to put in the total points. Okay, so we're going to set that, so that would be what we'd call initialization. We mentioned also, talk about what's stored in grade and what's stored in name is text, or sometimes referred to as a string of information. Okay, it's really stored differently than the score or the percent, because those are numbers and the total points. Those are specific numbers. They're stored with a characteristic of mantissa, whereas here in the blue, or if you can't see the blue, the grade and the name, they're a string, they're text. You know, they're letters, they're information in terms of you don't do calc. Here's the flow chart. So we got to start. It's a little hard to see that, but that's where we initialize the, you know, the total points equal 50. We got the score and the name. Then we figured out their percent. And then we looked, is the percent less than 0.7? If it is, based on our criteria, we print not learned. Okay? If this is false, the score must be greater than 7, so we look to see if it was less than 0.8, the percent. And if it's less than 0.8, we know it's greater than 7, then they must have gotten a C. If they, and I forgot my false here, if it's, I'm surprised a student didn't catch that. So if it's false, you look at this category, if it's false, then we go down and print the A. But if this is true, we're going to print a B. You get it? How that flows? This one comes back over here, and they come back together here. And then we stop. Last thing is the pseudocode, and I show that here. And you can see this if then else, and then I'll show this one in red. Then this one is embedded in that one, and in blue this one's embedded in that one. And that's enough for now.